Hey guys, this is lesson 4.7 on law of sines and cosines. And some of you have done a little bit of this already, but for a few of it, it'll be a review. Some of you, it will be something new. But we're talking about using sine and cosine to find the sides and angles of triangles that are oblique triangles, which means I don't have any right angles in them. And so typically we use sine when we have a right triangle, but in this case we're going to be able to do it when we do not. Some things that we need to look for is that if we have a triangle where we're given two angles and then a non-included side, so would look something like this. Maybe we have an angle here, and then we're given this side so that A is a non-included side. We also may use it when we have a triangle with an included side. So in that instance, it would look like this. We would have an angle here, and then the side in between we would have. And then the third possibility is side-side angle, where we have a side, we have another side, and then we have an angle that's not included. And so that just means that it's not between the two sides. So depending on the given information, we can apply the law of sines to the problem. Now we're going to do some basic ones here. The law of sines says this, that the sine of angle A over the side A is equal to the sine of angle B over side B equals sine of angle C over side C. And in our triangle here just above that, you can see how it's labeled. We have triangle ABC, and then the side A is directly across from angle A. The side B is directly across from angle B, and side C is directly across from angle C. And so we always label angles and corresponding sides that are opposite each other. All right, so we have our first scenario here. It says round the side lengths to the nearest tenth. We have an angle, and then we have a non-included side. And so if we go back, you can see that that actually fits that first scenario, having two angles and a non-included side. I'm just going to go and label the parts that are not labeled here. So I have angle A, and then directly between angle B and C, I have a side A. I have an angle C and a side C, and then I have an angle B, and 20 then would be my side B. What I want to do is solve for the triangle, and that means find out what all of the angle measures are and all of the side measures are. Before I get started, I'm just going to make a list. So I've got the measure of angle A, measure of angle B, measure of angle C, and then I have side A, side B, side C. Anything that I already have, I'm going to go ahead and fill in. So angle A is 35 degrees, angle B is 103 degrees, and side B is measure 20 units. Anytime I'm given two angles, I can solve the third one just by subtracting from 180. So I'm going to do that. That's the easy way to get that first measurement. So the measure of angle C is equal to 180 minus the sum of the other two. And so that's how I'm going to get angle C, which gives me the measure of angle C would be, looks like 152, or I'm sorry, 52 degrees. How about 42 degrees? Okay, so now I have angle C. That's 42 degrees. And then I can use that when I'm solving. Now I can apply the law of sines. We have sine of angle A over A, sine of angle B over B, sine of angle C over C. Angle A was 35 degrees, so I would do the sine of 35 degrees over angle or side A, which we don't actually have yet, so I'll put a little A there. Sine of angle B, which is 103 degrees, over 20, because we do have that side, and then sine of C, we found out what that angle C was 42 degrees, and then we can still solve for side C. Now, even though it looks like I have 3 ratios altogether, I can still only solve 2 ratios at a time. You just want to make sure that you have one of your ratios that's complete, and that means that you have numbers for both the numerator and denominator. Then you can put 2 of those ratios together. As long as you're only missing one part, you should be able to cross multiply to solve your proportion. So in this case, I'm going to take A times the sine of 103 and set that equal to 20 times the sine of 35. And we'll divide by sine of 103. Notice that I didn't go ahead and simplify the signs. I'm going to just put all of this in my calculator at once, and that keeps me from getting my answer too far off, because I am going to end up approximating here. So what I want to do is take 20 times the sine of 35 over the sine of 103. We'll see if my calculator will pop up here. Oh. I was hoping to shrink it up a little bit, but maybe not. So we'll clear that out. And so I had 20 sine of 35 divided by the sine of 103. And I'm not sure whether I'm in radians or so we'll just see what happens here. So in this case, actually, I was in degrees. If you're going to put degrees in, you need to make sure you're in degree mode. And I was in degree mode. If you were doing radians, you would obviously do radian mode. So my solution then is, I think it says round to the nearest tenth would be 11.8. Okay, and then after, so you've got that value, we would finish up the problem and solve for C, doing the same thing, cross multiply. I would probably set my proportion up with those 2 ratios in order to solve. So this problem is not finished. I would want to go ahead and do C, and then I would be done there. Here's another one where we're applying the law of sines. In this case, we have an angle side angle, which also applies to what we did before, and we could set that up the same way. So we have ship A, ship B, and then port will let be C. And so the side opposite, ship A, we'll just give that an A. The side opposite ship B will be a B, and the side opposite the port, we'll let that be C. And then it says find the distance from the port to each ship. So when we're going to solve for B, which would be the distance from port A to ship A, or from the port to ship A, and then we'll solve for A, which would be from the port to ship B. But it's the same problem. It fits the criteria that we need for the law of sines, so we'll be able to put that in the law of sines, and you'll be able to cross multiply there. Again, as long as you have one complete ratio. Now, when you first go out and fill this in, you might say, oh, well, I don't have one, but you'll notice that you do have two angles given already, so you can easily find the third angle, angle C, there by subtracting from 180. This next situation, this is called the ambiguous case, and we're not going to look at this today until I come back. But we certainly have to look at other scenarios that can happen where we can still use the law of sines. And it's possible to have a situation where you have no solution, one solution, or two solutions. And like I said, when I get back, I'll talk about those things. Okay, so that was just our little preview there of the law of sines. Actually, you know, let's go back just 1 minute here and see what happens when we have an angle measure here. So in this case, I have a side-side angle situation, and it should work out where I'm going to have one solution. It's possible to have no solutions in some cases, but this one's going to work out, and it's going to have a special situation here where we don't know an angle, and we're going to solve for the angle. So I'm still going to use law of sines, sine A over A, sine B over B, and sine C over C. But this is just what do we do when we're solving for an angle measure? Because here we can't just subtract from 180. I know that the side A is 94 and side A is 15. I don't have angle B or side B. I don't have angle C, but I do have side C, which is 12. So in this case, I do have one complete ratio. That was the one where the A's were at. I have nothing for B. That doesn't mean that I'm not going to be able to work towards it, but I can't do anything yet. So I'm going to take these two that I have circled here, and I'm going to solve using a proportion because I'm only missing one value. And I just wanted to see what that looked like when we're missing an angle. So I have sine of 94 degrees over 15 equals sine C over 12. And we would cross multiply. So I'm going to have 15 times the sine of angle C equals 12 times the sine of 94 degrees. And we'll divide by 15 because we're wanting to solve for C. And right now that sine part is looking a little tricky. So we've actually want to get the C by itself, we've got to get rid of the sine. I'm going to do the inverse sine. So I'm doing sine inverse. And that's going to get rid of the sine on the left side. And this is what I'm going to put in my calculator. I'm going to put sine inverse of 12 times the sine of 94 all over 15. That's what I want to put in my calculator. So I know I'm going to do, I'm in degrees, so I have angles, or I have degree mode. I'm going to do inverse sine of, and then I got my parentheses. It was 12 sine of 94. Make sure you end your parentheses there. Divided by 15, I believe. And so again, I want to do the whole thing. And when I hit enter, it should give me, this is an angle measure. And so the measure of the angle is about 53 degrees. Now I have an angle to put in there, which would give me two angles. So I have angle A, I have angle C, and I can subtract one from 180 to solve for B. And then I can do a proportion to solve for side B. So that's how we would go about that situation if we're missing an angle measure, is use inverse sine. All right, on to cosine. So what happens if we don't have the situation that we need for law of sine? So law of sines, you have to be given angle, angle, side, angle, or side, side, angle. If you have, so if you don't have one of those scenarios, what do you do? Well, then we have what's called the law of cosines. And for that, if I'm given side, angle, side, or side, 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 then I can use the law, what's called the law of cosines, to solve for the oblique triangle. And we've got our different equations here. They're really all the same equation, and I just kind of want to break it down for you just a little bit. It really depends on what side you're wanting to solve for or what angle you're wanting to solve for. So if you're trying to, or even like what angle you're given. So if I'm trying to solve for side A, I am going to start my equation with the A. Or if I'm given angle B, then I want to start it with angle B because I already have that one. It just depends on what parts you have, but it's helpful to memorize this by comparing what parts you have. So in all of the different scenarios, whatever side it starts with, that's the angle that it ends with. So we're going to take the cosine of that same angle. And then we have our equal sign. And we'll have the other two sides. We're going to add their squares. And those are the same ones that we multiply in the later on in the equation. So it always begins with the same letter and ends with the same letter. So if I start with side B, then I'm going to do cosine of angle B. If I start with side C, I'm going to end with cosine of angle C. And then it's going to equal the sum of the squares of the two other sides minus 2 times their product. And that helps me to memorize this just a little bit. All right, so I have in this example 5, apply the law of cosines. A group of friends who are on a camping trip decide to go on a hike. According to the map shown, what is the angle that is formed by the two trails that lead to the camp? What is the angle formed by the two trails that lead to the camp? So I want to know what this angle is right here. And we can give them some letters. I might call this angle A, B, and C, which would give me side A, side B, and side C. So I would definitely label those to have something to refer to. We know that we want to solve for angle A. So that's probably the equation that I want to use. And so the angle always comes at the end, which means I'm going to use the form of the equation that says a squared equals b squared plus c squared minus 2bc times the cosine of angle A. And I chose that because I wanted to find the measure of angle A. And then we're going to go and substitute everything in that we know. We have side A. And again, this is a good candidate for cosine because I'm actually given side, side, side. So in our equation, we know everything except angle A here. So we'll simplify that. This is 2.25 equals 4 plus 1 minus, and this is kind of tricky because a lot of people will want to actually subtract that, but you'll notice that this is multiplied times cosine A. So that is minus 4 cosine of A. We can put this together, we just don't want to subtract the 4. Again, order of operations, it's multiplied by cosine of A still. And so I'm going to subtract 5, which gives me negative 2.75 equals negative 4 cosine of A. Okay, and then we'll divide by negative 4. And I'm not going to divide this all the way out, but I can simplify the negatives here. 2 negatives make a positive. Just leave it like that because we're really concerned about A and not what 2.75 divided by 4 is. And then I'm going to do inverse cosine because I want cosine, I want A, not cosine of A. All right, so now I get to use my handy dandy calculator. Maybe. Oh, it's under there. Okay. And we're going to do inverse cosine of 2.75 divided by 4. And it says, so that's our angle. It's about 47 degrees, angle A is. And that's our answer. Okay, we have another situation here. This time we have side angle side. Similar situation is going to happen. We just don't have all the sides this time. We do have an angle. It says round the side lengths to the nearest tenth and the angle measures to the nearest degree. I'm probably going to start with the equation in the form c squared equals a squared plus b squared. Again, I'm using if I start with side C, inside my equation is going to be the other two sides. And then to AB, so I repeat that A and that B, times the cosine of angle C. And I did that because I'm given an angle there and I want to be able to use it. And we can substitute everything in. We have C squared is equal to, so this is side A, this is side B, 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 65 degrees. Again, we're down to just one variable to solve for. It would be 80 cosine of 65. And honestly, I could just put all of this in my calculator if I want to solve for c, take the square root of all of that. So I want to take the square root of 25 plus 64 minus, and we said that was 80 cosine of 65. So it's all under the radical. We didn't have to do anything extra. We hit enter, and we get about 7.4. So side C is about 7.4 units. Now we've got enough information that if we wanted to, we could use the law of cosines again, or we could even use the law of sines. It really is up to you, because now I have side-side angle. So it could work out that I could use the law of sines there, or I could use the law of cosines. And then we would want to solve for the rest of the parts. Okay, so now we can find each of the parts. What happens if we want to find the area of the triangle? And so usually we do area of a triangle is 1/2 base times height. But what happens if we don't have that information? What happens if we just have all of the sides? Okay. And so I would use this if I had side, side, side here. And notice in our area formula, we've got the sides. Now, the S here, we've got side A, side B, and side C. The S is actually the solution to an expression 1/2 A plus B plus C. So you've got to solve for that first. You'll notice that in example 7 here, it says use Heron's formula. Sometimes it's called Heron's theorem. And we don't have A, B, or C. It doesn't matter. The same principles apply. This would just be side Y, side X, side Z. And so in our equation, the area of the triangle would be the square root of S times S minus X times S minus Y times S minus Z, not C. S minus Z. So same thing, we're just replacing A, B, and C with X, Y, Z. When we solve for the S, then we'll take 1/2 X plus Y plus Z. And that's what I'm going to do here. So I have 51, well, I'll go in order, 45 plus 51 plus 38. And so, let's see, it's 134, half of 134 is 67. So my S would be 67. Just going to double check real quick, but I'm pretty sure that's right. Yep. And then I can do my area equation. And And I have 67 minus 45, 67 minus 51, 67 minus 38. Do a little simplifying. Be 22, 16, and 29. So we'll go ahead and use my calculator. We'll do the square root of 67 times 22 times 16 times 29. And I get my area is about 827 units squared. Okay, and then one more here. So Heron's theorem, we had used side, side, side. It says it's also possible to find the area of a triangle given two sides and an included angle. So again, same situation here. Maybe we don't have the height, but we have side, angle, side. And we can find the area. Really, again, the format is all the same. It's just where they've changed the variables around. So for instance, I have area is 1/2 BC sine of A. If I'm going to use angle A, then I'm going to use the sides that aren't associated with it and use BC. If I use angle B, then I would use side AC in the equation. And if I am using angle C, then I would use side A and B. So I do have a side angle side here. I just don't have A, B, and C. Again, the situation is similar. We can just interchange those. So this would be side H, side G, and side J. And if I want to find the area of this triangle, since I have side angle side, I'm going to adjust it to my given part. So I'm given angle J, so I'm going to do angle J here. And so I'll do the other sides. So 1/2 times G, side G, times side H, times the sine of 108 degrees, which would be angle J. Let me put that there. And then we can substitute in. So we have 1/2, 10 centimeters, times 7 centimeters, times the sine of 108 degrees. And again, I would just put that all in my calculator at the same time. I would actually end up with, if I were doing this by hand, 35 times the sine of 108. And I get about 33.3 centimeters squared for my answer. So that's the area. Okay guys, I think we have enough information here. I'm not going to have you do the assignment at the bottom. I did give Mr. Condon a worksheet for you guys to do. And so you'll be using law of sine, law of cosine. You'll be doing Heron's theorem for area if you have side, 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 and you will be using the sine area formula if you have side, angle, side. So come with your questions, and we'll talk more about the oblique triangles and what happens when we have different solutions. It's called the ambiguous case. So we'll be talking about that the next time. All right, have a good day, and I will see you on Thursday. Bye.